Hello, welcome back. This is Calculus by Dr. Oz. Today, we're going to go through a specific set of exercises where we're going to practice completing this square. In both cases, you are given rational functions, and in the first one, you have a quadratic in the bottom. So what we're going to do is to write the bottom in terms of a perfect square, okay? So this is a specific algebra technique that's applied to certain integrals, and this is one of those. And in the second one as well, you have 2 divided by radical minus x squared plus 4x, and we have a quadratic under the square root sign. So what we're going to do here is that we're going to try to write that as a perfect square. And at the end of the day, for each of those cases, you're going to have either sum of the squares type bottoms or difference of squares type bottoms. And so that we can sort of like fit those integrals into one of the formulas that I'm going to show you in a sec. Here we go. So these are the integrals involving inverse trig functions. As you see, you have the bottoms either written as like difference of squares or sum of the squares. So, and in each of those cases, you have u and a, and u refers to a variable, and a refers to a constant, just a number. Okay, so and in our problems, the bottoms were quadratic. So if you're able to complete them to the square, then we can hopefully fit these integrants into one of those forms, and we can just like do the integration in one shot. And in the meantime, please refer back to the basic integration formulas right here, so that I have 18, 19, and 20. These are identical to what I just showed you in the previous slide, but I also have the integrals of basic functions over there. Please have this table with you, and we're going to refer back to that. All right, let's get started.
All right, so let's look at part A. We have 1 over x squared plus 4x plus 8. And this is a kind of question like we test your skills on completing the squared. Okay, so let's work with the polynomial first before even we tackle with this integration. So I'm going to complete this to a square. And there are certain formulas all over, but I think the one that I'm going to use is a very simple one. So here you go. You have x and x squared and 4x here. So why don't you write it as like x plus half of this coefficient here. And take the square of that as if this is equal to the perfect square of x plus 2. I'm going to write it in blue to see the difference. So quantity square here is x squared plus 4x plus 4. So this is what exactly this perfect square is equal to. But the original left-hand side is x squared plus 4x plus 8. So, and this is 4. So I should add probably 4 to make the left-hand side equal to the right-hand side. So here the rationale is that if this is just x squared, and if this comes with a number times x, it could be negative as well. Okay, we get the half of that and just place it back here and take the quantity square and expand it out. And then to match the right-hand side to the left, we sort of like either add or subtract a number at the end. So this allows us to convert this integral to 1 over x plus 2 quantity squared plus 4. And now I can erase this because I'm done with the completion of the square. So now I can deal with this integration here. Okay. And this integral is one of the known integrals because this looks like I have a u here, and I have, instead of 4, I'm going to put 2 squared so that this term looks like my a. Okay, 2 is like a. So let me just write it down carefully. A equals 2, u equals x plus 2. And now let's go ahead and use the u substitution. Du equals dx, right? Once you have u equals x plus 2, du equals dx, so that this integral is equal to du over u squared plus 2 squared. Now let's check out what this integral looks like. If you go back to the table of integrals involving inverse trig functions, this looks like you have the second kind of second formula, that is the arctan u over a type formula. So dA over the sum of the squares, a squared and u squared, right, is equal to 1 over a arctan u over a. So let's go back. This is equal to 1 over a arctan u over a plus c. And let's put the u and a back. So 1 over 2 arctan x plus 2 over 2 plus c. You can also put u over a with parentheses here. Okay. And I think this is the end of it. If I'm not wrong here, 1/2 arctan x plus over 2, x plus 2 over 2 plus c. All right. That takes care of part A. I'll see you in part B in the next video. Bye.